Hi everyone, my name is Yoshikatsu Ueda from Kyoto University, and my presentation title is a correlation between the radiation measurement on the field of prism KURAMA and environmental radioactivity in the third directions. This topic is international collaborative research with me and Professor Nihei from Fukushima University and Professor Natarampong from the Thailand Rajamanga University of Technology, Lana, Thailand, and Professor Tanimaki from the Kyoto Universities. And this is the outline of our research. We have three main topics. One is we measure the environmental session 137 around Fukushima. We have foreign radio session 137, session 137. Radio session is falling down from the Fukushima nuclear power plant in 2011 around the Fukushima. And still contamination radiation remained in the forest regions and around in the agriculture fields, kind of the small road and small river around the rice field. So in order to investigate the contamination of surrounding the peripheral agriculture field and the possibility on it to the irrigation water, we made a pollution map in 2018 and 2019, from 2017 to 2021 now. So we checked the environmental larger systems. For measuring the larger system, we use KURAMA, Kyoto University radiation mapping systems. This radiation system is equipped with two scintillation detectors and acquire the measuring position information from the real-time GPS receivers. So we can measure the surface ground counting rate just by walking, but the backup is very heavy, but we can walk. And the field, special field is prepared in Iitate Village agriculture field in Fukushima, and we have surveyed the paddy field the 500 meters times 200 meters in Iitate Village, and surface content rate were measured using KURAMA in Iitate paddy field. So we focus on the session 137 around Fukushima, and they still remain in the forest region far from the house regions. You can see this photo, you can see the soil is removed around the house near the forest region, but from the soil from 20 meters from the houses, so soil, contaminated soil is removed by the government, but still soil is radiation assessment is remained in the deep area of the forest regions. And also the farming area, we also removed radiation contaminated soils from inside the farming area, but some of the places still remain in the contamination assessment around the peripheral small road and the irrigation rivers, small rivers. On riverside is we do not anything because river water is flowing inside the water rivers. So the maybe many of the radio system is moving from here to these seas. So we do not, we have to check the kind of the river fishes, but this is another project by the Fukushima University peoples. And we introduced the radiation monitoring system KURAMA by walking. So this is a backpack photos. Inside the backpacks, we can see the urban receivers and the Wi-Fi routers and the two scintillation CSI detectors. Our upper scintillation counter measures the normal radiation level around the field, no ceilings. And the second one, lower detector is sealed it around the sealed by the leads, only is opened the downside of the scintillation detectors. So we can measure the surface ground level of the radiation levels in subground by the lower monitor or detectors, and upper detector can measure the around the measure the field radiation levels. So we can calculate only the ground level of the surface level detectors in this KURAMA systems. And this is installed backpack with by Professor Nihei with a PC tablets. We can walk the kind of this style, walking around the irrigation rivers and the paddy field and the around agriculture field. And it is almost 15 to 20 kilograms walking, so very tough work by us. And this is a kind of the photos, some photos by measuring with Professor Ratlampons in Fukushima areas. We can walk installing backup with her and around the paddy field internet village. And this is another area, and we are very this is very dangerous zone because the white boars are running around us. So this is a very, very dangerous area, but we can measure these areas by us. And also we discuss with Professor Natampon in the Thailand Science and Researches in Fukushima with Fukushima research groups. So we have very fruitful discussion in the 2018th. And our research field in paddy field is Itate village. In the Itate village is almost 50 kilometers from the Fukushima Daiichi nuclear power plant. And even the 50 kilometers, you can see that this is a radiation contamination level just after the 2011's exploding the Fukushima Daiichi nuclear power plant. And Itate is one of the most contaminated areas in Fukushima. So in the 2021, even now, we can check, we can measure the radiation cesium in the around the Itate areas. And the paddy field areas, you can see that these are very nice view graph, but this is winter season photographs. We walk around the kind of this color maps. And the paddy field is, you can see the purple color lines is inside the paddy field level, and these are almost recovered removed soil areas. So we cannot see any radiation cesium in the here, but you can see only here green and a little bit red point is this area is no contamination. This is no, still we do not remove any soils from here, so you can see high level radiocesium in the paddy field. And you can also see some of the sky blue and green one in the some walking area. This is a side road of the paddy field. So we have to check these paddy field areas, how many radiation cesium is still remained. And this is also the view graph of walking around the slopes. You can see that this is a slope photos, and from this walking aside slopes from the lower and upper. We walk here, like walking, and you can see the some part of the slopes. We found a little bit high level of the radiation cesium, and other one is we cannot see any radiation. And now we compared this KURAMA measurement data with this direct soil sampling levels. This is a direct soil sampling soils by like these two views. This is me. We take soils kind of the instrument, and we take some soils from the depth levels from 0 to 5 centimeters and 5 to 10 centimeters, and most lower 10 to the 15 centimeter soils. These three parts of the soils we measured by the another instrument, and we can check the cesium 137 radiation level kilobecquerel per kilograms. So now we can compare this soil sampling with KURAMA measurement, and this we can check the correlation between the walking and the direct measuring. So walking is very easier. It is very easy to walk around the KURAMA. It is just measuring maybe only of course, this is a tough walking, but maybe 5 minutes to the 1 hour we can make. We can walk. But the direct soil sampling is a bit. This is a very nice measurement ways, but we have to put soil sampling, and we have to back to the universities, and we put into the measuring system. So it takes almost 2 or 3 days, and maybe more than 1 week. So the 1 hour and 1 week measurement is KURAMA is a very easier system, and we can check the everywhere by walking. So this is the correlation between the soil samples and the KURAMA data. Total average means we mix the we mix all of the soil samplings and put the KURAMA data between the upper side of the slopes and middle side of the slopes and lower side of the slopes. And depth level 3 to 5 centimeters is the surface of the soil. We collected the samples, and we checked the almost same place. This means almost here. For example, number 4, we collect the number for the upper areas and middle areas, or the lower areas of the KURAMA data we collect, and averaging the data. And we compare with the direct sampling of the number 4. So this collecting correlation between the average and depth level, for surface depth level, we found the very nice correlations between the KURAMA data and the depth, surface depth level from 0 to 5 centimeters. And correlation coefficient determination is very nice from the upper, middle, and lower is a little bit not good. And the other depth levels, you can see the depth level is the middle from 5 centimeters to 10 centimeters. Correlation is a little bit dispersed, like from the 0.7 to the 0.58, and depth level from 10 to the 15th. This is more deeper state, deeper soil on the surfaces. So we can see very bad coefficients, COD, even the upper and middle and lower. And in this result shows in the lower case, you can see the KURAMA is measuring the surface level of the soils, and also KURAMA have measured the side slopes, or middle and upper side soils radiation is measured by the KURAMA. So our lower side is correlation is a little bit bad compared with the upper side level. So this is very nice correlations, and we can explain these correlations. And even this is one problem is you can see the exact level of the soil becquerel per kilogram is higher than the KURAMA data. KURAMA data, you can see the 1,000 to the 7,000, maybe 5 to the 10 times larger than smaller than the soil level. But we can calibrate this data. So this is not a big problem. So in conclusions, we can measure the KURAMA. We can measure the contamination level of the radiation settling along the paddy field slopes. So by the KURAMA, we can precisely measure the soil contamination level by KURAMA by walking. And in comparison, radiation density of the soil is determined by soil sampling, and the correlation is high in the upper of the soil. So, and we can calibrate and recalibrate this data. From this data, we can check the precise soil surface level of the soil radiation sensing by KURAMA from now. And the correlation gradually decreased. Correlation COD is decreased by the depth of the dose 5 centimeters. This indicates that the measurement allows KURAMA or measuring the radioactive contamination density of the soil up to the surface layer of 5 centimeters. And the influence of the radioactivity of the slopes, the correlation coefficient also decreased by the bottom slope. So this is also the problem, but we can check we can calibrate from this data after this research. So we can do we can collect the nice data from this view, our studies. Thank you very much.